Workshop. In this session, I'm going to give you more details of the code, the parts that we have implemented, and then the somehow idea that we had on the back of this development. And then after that, I'm going to show you how to set up the environment to use openCHA, give you some examples, and then teach you to implement one simple task on how to, for example, add a simple task and then use it. And then, yeah, this session will be over. Let me share my screen. Okay, so before starting the explaining the code, I want to give you some high-level ideas of how this code we were writing it, why we wrote it this way, and what are the ideas that we had behind this to make sure that all of us are on the same page. And then I will go deeper into the details of the code structure and so on. The thing is that because this area, this openCHA conversational health agent are some kind of multidisciplinary area, and the people who are going to use the system or developing, or the community that is going to be built around it is not only tech-savvy people. We want to make sure that people with less or little hands-on knowledge on Python also can start using it with at some level of configurations, and then they can also interact with it, try it, and if they need to add some tasks, they will read some proper tutorials and explanations. They will be able to integrate what they have already built in their labs and so on into the system without any burden. That's why we try to create this openCHA in a first modular way, and second in a configurable way. It means that most of the things that we have discussed here in this architecture can easily be configured. You already saw how we are configuring or selecting the tasks. We simply select them from the dropdown without any hassles. And then for other components that we have here, we try to do the same thing, but at the code level, that you can simply select what LLM you want to use for the planner, what LLM you want to use for response generator, or what kind of data pipe implementation you want. Some may be interested in simple in-memory data pipe, or the other one may want to have a database speak fast real-time access or other things. So for each of these things, we try to write the code in a way that you can simply configure them. Just to simply show you an example of what this configuration means. Here you see that we have some initializations for each of these modules that you can simply configure the planner type. That, as I've mentioned before, we have right now React and Tree of Thought Planner implemented, that you simply, in the initialization, you can select this configuration as your base model. Or for data pipe, you can simply say, I want to use memory. For LLM, for the planner, here we simply select OpenAI. That here you can see that we have implemented OpenAI and also Anthropic. And as I've said, the goal was to make sure that everything can be configured very easily, so the developers and most CS researchers can concentrate on creating more configurations to be used, like adding extra LLMs, adding extra tasks, or other planners and so on. And those people who want to use it to build their own agents for a specific downstream task, for evaluating the capability of this agent in a specific domain and so on, they are able to simply select those configurations and do the evaluation. Like currently, the example could be that in ChatGPT, they are trying to, the medical side people mostly try to come up with prompts or different ways to test if ChatGPT can answer like mental health questions in a proper way, then they evaluate it. Here they took one small extra step to set up some base agent that they want, which contains the models, the LLM they want to use, the planner they want to use, the types of tasks they want to be used in the agent. And then when the setup of the agent is completed, they just start interacting with it, and then they can simply evaluate what is happening. So this is the whole idea behind what we have, which we also try to configure the basic openCHA in a way that with no extra effort, you can have the best working model that can plan the best way possible and also answer the questions and access to the tasks that are working the best way possible. So even for those who don't want to get into details of what LLM to use or what technologies to use, we've made sure that the initial configuration is the best one, which is working right now. So knowing this, going back to the structure of the codes that we have, it's completely aligned with what you've seen in this picture. We have some external sources which are represented as tasks. That tasks can be some AI models, they can be some access to some knowledge or implementation of some knowledge bases and so on, or accessing some data sources or translation models and so on. That all of these, we call them tasks. And you can develop different tasks with different inputs and outputs, and I will go into details on how to define those tasks. And then this categorization that you are seeing here is some kind of conceptual categorization to help people understand what are the possible sources. But in the code currently, no matter which of these categories, we call them tasks. And then we have interface. We try to use open source interfaces exist right now, which the most publicly used is Gradio in Python, that we use this so that it can be reusable. People can create components, visualize components if needed on top of what we currently have, if their task needs more high-level interfaces that right now doesn't exist. And then inside the orchestrator, we exactly have the components, the same names that you are seeing here. We have response generator folder that contains the implementation of the response generator. We have task planner that contains the implementation of the task planner and promptist, and also the orchestrator itself and the So the whole architecture is aligned with what you are seeing here. The folder names are also the same that you see here. We have an interface that if I go in it right now, we have one base interface that is using Gradio to create the models. And then we have planners, that different types of planners like Tree of Thought and React Planner are implemented here that you can simply see them there. And so for each of the things that you are searching for, we have a folder here that you can dig into them and see what is happening. There is a common structure exists in all of these folders. And the reason that this structure is repeatable is first to reduce the learning curve of how to customize the code. And also it's for the configuration and configurability that I've already mentioned, to make sure that all of these things can be configured. In each of these folders, you will see some files named types and the folder underlined types, which these take care of different implementations that exist for that specific component. For example, here for LLMs, we have OpenAI and Anthropic implementation exists. And if we go into the LLM type, we see that we have these two as two possible configurations for LLMs. For today, I don't want to go very deep into all of these components. The important part that we want to more investigate is the tasks, because we assume that most of these LLMs, planners, and these things are maintained right now. And the most demanding part that exists right now is to build an application on top of openCHA. Like you have your own models, you have your own knowledge bases, databases, and so on. And you want to see how you can build a task or multiple tasks, and how you should design those tasks to be connected and integrated into openCHA, and then you can start using them in our openCHA framework. I just wanted to show some examples to know that the whole architecture that I'm going to explain in task, it's repeated in other parts. So if you wanted to dig into those parts as well, then you will see the same thing, and you have a high understanding of what is happening, and you can easily navigate through them. So as I mentioned, today we mostly will go through the task part, but before that I want to mention where the whole thing will get started in the system, and it's orchestrator. That here in the orchestrator we manage all of the things that is happening, all the connections between different components that exist at exactly what you are seeing here. That orchestrator will receive queries via interface from the user, and then the task executor identifies what should be done with this, if there is some metadata or if it's the text itself, and then it passes it to the task planner. The task planner, based on the query and existing metadata, decides what available tasks can be used, and then initiates the execution of them. Then those plans will be conveyed to task executor. The task executor connects to those tasks, it executes them, and then the final result will be returned to response generator. Their response generators will have a bunch of prepared, analyzed data from different sources which planner have initiated. And then we ask the response generator to bound the answer to those reliable, existing, and prepared information. And then in the end, the response generator LLM will provide the final response to the user. Here in the response generator, we made it in a way that you can add some prompts to make sure it's more empathetic, or it understands the user feelings, emotions, and so on. So there are some configurations like this as well in the code that I've already mentioned. There is a question here: the data pipe memory can handle, does it depend? Yeah, sure. There is a question here. I will read it. It says that how big is the data set the data pipe memory can handle, and does it depend on the machine running the code? Does it save it data locally? Yeah. Currently, everything is run locally, and it has its benefits and also its drawbacks. And yeah, it depends completely on the machine that you are running locally. And data pipe currently is a simple memory. It's like an array that stores all of this data. We just wanted to showcase how this memory can be used. And the reason that we have this data pipe, as mentioned before, is that many of the data that we have from healthcare are raw data and big data that by themselves, they don't have any information or context by themselves. Like, for example, if you have a PPG signal, it's a big raw, like megabytes of data, like some numbers, that giving this to LLM directly may not give it any idea of what to do with it or how to react or use it. And also the other problem is the token limits, that if we provide all of this data directly to LLM, even if it knows it, we pass the token limit in many scenarios. So that's why we have a data pipe here to store those intermediate information in a separate place. Make sure we perform the needed analysis and tasks on those data, and then the result of those analysis and processes will be returned to the LLM. So they are more compact, they contain more high-level information that the LLM can use to answer the user in a proper way. For example, in the stress estimation example that Iman mentioned, there you have PPG data. We want to extract stress out of the PPG. One way to do it is to extract the heart rate variability out of the PPG, and then using some AI models, you can extract the stress out of the heart rate variability. This is a three-step process and analysis that should be done on top of the raw data to extract the stress. And if you directly put the PPG data to the LLM, it cannot give you the correct answer, and also it may reach the limits of tokens and so on. So that's why we have something like data pipe here to handle these things. But yeah, it directly is dependent on the local machine which is running it. Okay, getting back to the code. As I said, the orchestrator, so is trying to orchestrate everything, and the whole scenarios and the whole things that Iman showed you happens in this orchestrator, and it's the main core that we aim to maintain. And we hope that the community can come and help us to both develop these components or develop extra tasks that can be used for a specific downstream applications in healthcare and so on. So now, if you don't have any questions regarding the high-level thing, I want to start showing you how to set up this openCHA locally, how to run it, and then run some sample question to see what is happening. After that, I will show you some logs in the terminal that shows how this whole process is happening, that we are trying to show it in the whole system so you can track it, see how the model is thinking, how it's planning things, how it fetches the data, and these types of things. And then after that, I will go through showing you how to add a sample test. Okay. Is there any question till now? The audience is okay, great. So to start setting up the openCHA on the local system, we in the docs website of us, we have provided a complete detailed information of how to do the setup, containing all the containing images and samples of how to do it, and also we prepared the video that you can take a look. Currently, I'm going to go through all of it by my own. To
one question. So we sent this information 2 days ago. Anyone tried that, or any question?
I've installed it, but I'm at the key part where we need to install the key.
Like OpenAI key?
Yeah, both key.
The 2 keys?
Yeah.
So okay, so I will share with you this OpenAI key just right now, but for this Serp API key, you need to get it from this Serp API website. If you just like go there and then on the website, so if you register, it gives you like one free key.
Yeah, I've registered. I'll find the key somewhere.
But for the OpenAI, I will send you immediately. So just
yeah, for the next session, we are going to provide you an OpenAI key that you are going to use during the session to work with the OpenAI without any problem. I will use it here to show you how it works, and then Iman in parallel will send it to you, so you can, if you want to go through it with me, you can use it. So following this instruction, one thing that we recommend is to install a separate virtual environment to install everything of openCHA there, to make sure that it doesn't conflict with your current existing libraries and everything is consistent. And also try to make sure your Python is 3.10 or higher, because lower than that there are some warnings, and also lower than 3.8 it's not working because there are lots of new design patterns and changes in OpenAI that we would like to support. So to start creating the virtual, we simply run the virtual command. Here you need to pass a name like VN values here. Oh, sorry. Yeah, Python 3. Yeah, and then it will create a virtual for you. We have a question here. I tried using. Yeah, it's 3.12 because it's newly out. There are some changes there that we cannot support right now.
This is for the OpenAI.
Yeah, it's mostly the OpenAI problem, I think. I'm not sure if they've fixed it.
So try to use like 3.
Yeah, 3.10 is the best one right now that works.
So 3.10, okay.
Yeah. And
Yeah,
then
I
when
had
this,
to use like Python 3 instead of Python for that command.
And then the problem with this 3.12 is like this OpenAI library. It doesn't support 3.12. So if you're using your own LLM, so you could use it like 3.12. But
also some other tasks and libraries that we right now using are not updated based on 3.12 because 3.12 has some major changes in some parts. So it's better to right now stick to 10 or 11 for now. So I've run the VM, and as you see, there will be a folder named VM created. Now, what we are going to do is to activate this environment to make sure what we are going to install will be there. To do that, simply use source and then go to the VM bin and then activate. Then as soon as you activate, you should see VM here. It means that right now you are on this virtual environment, so you can start moving forward. The next step is to clone our code. That you simply clone it here, and after cloning, you will see a folder named CHA.
Then you need to activate it.
Then you go into that folder, and now we need to install the dependencies that is needed for openCHA to be working. We have separated the dependency in two ways. That one is that you can install the minimum requirements that can enable some tasks like searching in the internet, extracting tasks from some websites, or reading some information from data sets and so on. And but the all dependency contains all high-level needed dependencies like PyTorch and many other libraries which is needed for AI models and so on. For now, we try to stick on the minimum one because it takes time to install all of them. So to install it, you simply type install minimum, and then it will start installing all the minimum requirements which is needed. Most of them I probably have, so for you may take more time.
Is this part like so far clear? Because you need this for the like the next session for the exercise. People who are online. So is it clear or any question?
Asking for the source part.
So yeah, the part where I don't get it is when I type in source activate.
You are using.
It doesn't recognize source.
You are using Windows. Are you using Windows or like
Windows?
Windows. So you need to use like.
So in Windows,
It's like the source. A script activate.
let me see.
So
So I have, this is fine. I did the first step.
yes. So it's like then.
It's a long time I haven't used Windows, so
Yeah.
Yeah.
So this is.
And then PowerShell.
Yeah, so you're using.
It seems that you can simply in PowerShell. Do you see this? You can try this.
Yeah.
Yeah, in Windows, in PowerShell, you can go to the scripts folder and there is a file activate.ps1.
So this is.
Yeah, security.
So it's all been business. What you're saying should be outside. Source. Get inside. Network. Yeah.
Going to directory and then typing, yeah. You have some comment.
Okay. Okay. Yeah.
Just like pip.
So is that a one-time override or?
No,
did you change it?
Yeah, it's like a one time. So you, in the next time you need to do it again.
Whatever
I
you
guess
did.
so. I just like this problem. This is
Yeah,
something
and
that-
Yeah, thank you for
copy this
Vivek
one.
for sharing the
This is a problem.
info for Windows
Yeah,
people. You
So
can
this
use
is like a PowerShell
this
problem.
technique
So
to
they
go
gonna
to the folder and use the
run.
scripts activate
So you just like
to activate it. And also, if you
the next time
you
that
have
you
Windows
run it again in
version
PowerShell
11
and you want
and
to activate
later,
this one, you need to
you
just
can use an open
and
Ubuntu
then so you let the PowerShell to run this
interface called WSL that is easier to use because you will have
and
that
then now you can install
Ubuntu
like this
interface and everything is based on Linux. So many of these things would be easier using Linux.
Thank you.
Okay, so assuming that you were able to install the minimum requirements, now the next step is to provide the OpenAI key to let the system be aware of the OpenAI key, and then when we start interacting with the model, it will use it. So I've already
This is
written
for
the
again like for like Linux terminal, not for Windows.
yeah.
So for the export, I already shared like this OpenAI key with everyone. So for the Windows, you need to use $X. Let me.
And probably
Just
you can share it
$N.
in the chat.
Yes, sure.
Yeah, so for those who are using Windows, you can check the chat. Iman is putting the way that you can export the OpenAI key. We have shared this key with you via email, so you should have access to it.
How long can we use the OpenAI key for this?
For this
exercise?
session, yeah, we
Because
have
this is a paid key, so
yeah.
we use it for this exercise, and then yeah.
Yeah, we've enabled this to be used during this today's workshop, and after that it will be expired. So you need to go to the OpenAI website and create a OpenAI key by yourself and start a billing or payment API key, payment-based API key. Our experience is that your normal usage would be less than $5 a month, so it's not a very high costly thing.
You can use it for this session. So
Yeah, for the session today, till the end of this workshop, you can use this API key.
And in the chat, for the Windows users, I added like this. You need to place the key between these double quotations for the OpenAI key and also for Self.
Yeah.
Just copy and paste and
Simply
yeah,
putting this inside double quotes. Okay, so after we set up the OpenAI key, one last remaining thing is that for the extract text, which extracts information from different websites, we need this tool to be installed, and you need to run also this command in your command line, which I believe because I've already installed. Yeah, it doesn't show anything for me, but for you, you will see an installation process. This will install a simple Chromium browser that this module, this library will use to go to the websites and extract text and
have you done this?
extract text of that website and then return it to our openCHA.
Yes.
Okay. As soon as these things are ready, now we created a simple main.py file that you can see here, that you can simply run this file. Python, let me see it. Python return main.py. And then it should take some time to initialize for the first time, but after that, when you're interacting with it, it's not taking too much time. And when this is done, it will show you a URL that you can navigate to it, and you will see the interface that we have created. This is one way to open up the already implemented interface and use it to select the task and doing everything. But the other way is to simply write the code by yourself. And as you can see here, inside the examples, we are showing different ways that you can run. One is run with interface. One is if you don't want to run any interfaces, you can simply select the tasks that you want to use and then create a way to interact with openCHA, simply instantiating openCHA and then run your query. That here I'm inputting from terminal, from Python. I'm saying that ask you a question, then in the terminal you ask the question, then the question will be asked from CHA, and then the response will be printed. This is a simple without any interface way to do it.
Should be able to.
Okay, so when this is run, you will see a URL probably the same that I have here. Now, if you go to your browser and navigate, you will see that our interface will be up and running. Here we have a drop down that you can select tasks, and also we have a box that you can ask your questions. For now, I'm going to simply test the Google search and extract text and simply ask how to improve my sleep. Let's see if we have to test if we have set up everything correctly. Then as soon as I hit
Where's that screen? We
enter,
need to type
the
127.
system will start processing my query. You will see some
You need to go to that.
informative
Okay, yeah.
logs here that, okay, the tasks are successfully initiated, then the planning is started, then you will see some context of the
Super.
planner. And then you see, for example, this here, the task is executed, but it has some errors that we will go back to it. Then here the model was able to do it. I'm seeing this error. Okay. And then, for example, now the Google search task is performed correctly.
I have both keys.
And then it searched for this thing. And as you see, it is
Sort of
ensuring
API
that
and-
it's searching in a specific website to not get false information, and then the Google search task return the URL that contains the website that contains those kind of information. And after that, this result of the search is returned to the extract text to go and extract the information out of the website that is returned. Now, as you see, we have an error instantiating the. Let me stop this. Okay.
Yeah, not sure.
We have an error instantiating the executing the extract text, and it's showing here. So I will go to this debugging techniques later, but you will see that if there is some errors regarding your tasks and these things, you will easily see it here. This problem is because I've already have some Chrome installed that is not compatible with the one that we want. So
Yeah, you need to also like run this playwright install.
yeah, I've done it, but because I've already installed another version, it gives me an error. So I need to check this. Yeah.
So this is the answer, and this is the website.
Okay, we have one question. Is it possible to use CHA as an API and create an interface? Yeah, you can also use this interface to ask in different languages. And here we have a Google Translate that if you enable this task, when you ask question in another language, it will be translated into English. It runs the whole planning, and then after that, it will return the answer in your the source language. For example, if you ask the question in Indian, then you will get the answer in Indian. But the whole planning thing and all of this thing will be done in other languages. So let me delete this file. Okay, should run the playwright again. Okay, this is when you run the playwright install, you will see something like that. Start installing the Chromium browser. Then after it's installed, we should
That's
be
the
able
Git,
to use the extract text.
Yeah, it takes a while.
Meanwhile, if you have any questions, you can ask in the chat, or if you have any problems, you can share it with us, those who are online, so I can help you pass in this stage.
Is it now working?
Oh, been a long, it's been stuck here for a
Which
while.
one is which one? Okay, so it's just like run.
It's just running.
And I send you this to your Gmail. Yeah. So do you have? So you already
have a question?
Yeah, would it be possible, let's say, we have a local
No.
database
Not
and we use openCHA to, let's say, run to use LLM write queries,
Yeah.
SQL queries, and do subsequent tasks on that.
Yeah. The question is that can we use openCHA for using accessing some local data sets and running some RAG-based tasks? Am I right?
Yeah.
Yeah, all of these are possible. You just need to implement a specific task doing those things and then enabling them into the openCHA, then you should be able to use it. And the session that we have after this, we are going to implement something like that, that we have a local database, that we create a task to access that data and then perform analysis on top of it.
So I assume that that's something similar to the code base and the task module.
And
Right?
then do you have also certificate?
Can you speak
So
louder?
I assume the best way to start is look at the task module.
Yeah. I will show you after this when we see everything is working. I'm going to show you how to add a simple task that then we can make it up and running, and after that you can create your own task the same way.
Got it.
Okay, let's try again, see if our extract text is working. How to improve this? What's the question? Can you give us an overview how to handle external data source PPG data? Yeah, sure.
It needs your email.
For this next session, we are going to implement exactly one sample of this, that instead of PPG, we are using some time series of sleep data of people, that your task is to implement some external sources that accesses to those data and then perform some analysis. Right now, I'm trying to cover the basic things that we have, and then how to add tasks. Then in the next session, you are going to implement it by yourself.
What's the relationship?
In the
with
next
what we're
session,
selecting
you
here
probably have,
and the result?
you are hearing from two computers.
Like for example, these are like the internets. One, and then the one that we showed you about accessing data, like sleep data or like stress data. So these are like other tools that we define, but you cannot run it because you don't have the data
Okay.
here. We will give you data for the exercise, and you define this. So you define this,
Okay.
and then you select it.
Okay, that's the next exercise.
I'm seeing that we have only one
So extract text,
microphone here.
what's that task?
Probably because here also in the in-person, some people are typing and debugging some things. It may be
Google.
And the
problem.
extract text,
Okay, now the extract text is working. As you can see, the Google search done the search for top 10 habits to improve. This is the thing that the LLM planner came to it by itself.
terminal.
We didn't give it any instructions. That's one of the beauty of this work, that the planner, the reasoning part, which uses a planner LLM, which is a tree of thought that I will show you shortly, tries to come up with the best query that should be searched in the internet. Then Google search will return a link. Then the extract text will extract all of the content exist in that website, that you can see the return context. Then the planning, as you can see, is here finished.
So it just said that,
And
so I run
all of the data is passed to the
question did you ask?
result generator, answer
The
generator,
first one was what is
and
the
then answer generator use it to
Okay, just like copy and
that was the
generate
last
this
one.
response that you are seeing here. And if we click on this link,
so this is
it
the
exactly goes to the same
URL.
link that you are seeing here that was
The
found
input
by
is
the
like the URL that obtained in this
Google search.
and then it gets
So this is one of the ways that we ensure that we are accessing the reliable websites that we query
So
different
serve API is
websites.
to
We
access
can
the Google
bound this
search
Google
engine.
search to a specific website, like asking
This is
to
the regular
use,
search API.
Yeah, so you can use
Okay.
they're
For
like another one
example,
that we also defined, you can just like
for example, asking to use only search in the PubMed or only search in the
Google search.
specific
So you can also use that
resources that you will experience
difference?
during the
This separate is like
practical
more
session.
Oh,
There is a
free,
question,
so just
can we
like you have
extract, store, log,
Google
generated
search
planner
free
out
from
of
the beginning, and
Python
then after that you
code?
need to pay. But this is kind of more
I didn't
stable.
get your
Google
question.
search is
Can
the
you
free one.
rephrase it for me?
Doesn't work like all the time.
okay.
So
When you say doesn't work, it doesn't give always the same answer.
yes,
Can we see what
we
is
didn't
being
like this is a
executed? Yeah,
library.
the things
So
that
we
you are
didn't
seeing
define
here
this.
are exactly things which
So,
are executed. These are the
Based on
plans.
the
Okay.
application, you can
So now I'm
we
going
can
to show you how this
Google search.
planner
This search
worked
is like
here.
stable. So we
To
can
do
use it.
this, you
And the Google
we have a
search,
prompt
Is
that
it is
introduce
influenced by the
all of the existing tasks to our planner,
or do you have
and then
links and is
the
that
planner
influenced
uses right now the tree of thought. In the tree of thought method, we ask the model to come up with 3 different strategies. Then we ask it to provide pros and cons for each of those strategies, and in the end, select one of those strategies as this final decision to run the sequence of tasks. And here, because this example is simple, probably the 3 strategies are similar to each other that you can see here. but there are some differences in what to search. Like you see here that the thing that should be searched are different, and then it mentions the pros and cons. And in the end, it, for example, here decided to use a strategy tree. And then we pass this strategy tree to a code generator, that the code generator will generate a code to execute those tasks step by step. This is the second part that we have implemented, that we parse the strategies which is extracted from the tree of thought and converted into a proper code execution. Then we ask the Python to code this, to run this tasks one by one. And then the results will be logged here. As you can see, each of these tasks are executed step by step. And as you see here, the result of the search URL is passed to the next one. And you see some miracles here that I will going to explain to you when we are going to add a task, that how this knows, how the model knows that in this search result, the return of this Google search, there is something, there is a key named URL, and it's using it. Okay, great. I hope till now everything is clear for setting up and understanding how these logs can help you understand what's happening.
The OpenAI is for the
If you have any questions till now, please let me know. Otherwise, I'm going to give you some explanation regarding the implementation of the task. Okay, no question. So I'm going to open the current version that I've cloned, and I hope it's readable. Okay.
Now we can run it.
Okay. Yeah, it's better. So here, as I've mentioned, we have a folder named tasks, which we are going to implement different tasks here. Right now, as you can see, there are some pre-implemented tasks that can be used, like Google search that we have explored right now, like Google Translate that you can select to use different languages and then ask your question in another language, and like the extract text that we have discussed. So now what I'm going to do is to show you how you can add your task, the task that you want to implement yourself, how you can test it and how you can enable it in openCHA. To do this, in each of the folders, we have a file with the same name of the folder that contains the main class that you can inherit from to implement the needed components. And we made sure that all of the components which is needed to be implemented are somehow hardly noted, like making it abstract methods and so on. So we make sure that either you use the default setting or you are implementing them. And the adding task is as easy as simply creating a new class that inherits this one, the space tasks, and then start populating these information regarding your task, which I'm going to show you shortly. The thing is that for now, I want to select a simple task that we add a task that gives you the information of the time, the next time that you should take your pills, for example, and I simply just get the current time and then return it to the model, and then we see how model can use this task to give you the time of the next pill time that you should take your pill and so on. So to do this, I simply start creating a new task here called pill, for example, my pill time.py. And as I mentioned, we are going to create a class which simply inherits the base task.
Okay.
We name our class like my pill time, and then we inherit it from base task. There are some attributes here that you need to specify for each task. And as I said, because we want to make it configurable, they are simple. You don't need to do complicating things. These are some simple strings that you are going to populate and provide information regarding what that task is going to do. And there are some explanations that you can find for each of them. I'm going to copy them here and give you explanation. The first one is the name of the task, which we recommend to be the same name that you are seeing here. This name will be shown in the final task selection here. Okay, so you simply select the name. This chat name is for when the answer of this task is executed. This chat name will be provided to the LLM, so it knows that different parties took part to provide the answer. You can simply say my peel time here, and then you provide the description. You say this tool will return the next peel time. Next peel time that I should take my peels, users peels simply. And then this dependency mentions if this task is dependent on other tasks. For now, we don't have any dependencies. For this, we are trying to enforce the structure of the tasks. So you need to copy these as well to be imported here. And you don't need the data pipe.
So all of those data.
I think 10 minutes.
10 minutes?
Yeah. Okay. Yeah, so because we are limited in time, I'm going to be a little faster, but showing you how this example will work. So after providing the description, now we have two important components here. The first is the inputs, that you provide the description of the inputs and their format that the input should be received. For this task, we don't have any inputs, but for example, in the Google search, the input is the search query that we have, or for extract text, the input description is the URL that we want to be received. The output is the thing that we want to provide information to LLM to know, okay, what would the LLM expect to be returned to it. So here you simply can say the time of the next peel. So after this, we have two Boolean selectors, which defines if you want the input of this task to be stored in the data pipe, or you want it to be returned directly to LLM. If you make this true, the result of this task will be sent to the data, stored in the data pipe. For now, we just want to return it directly. This return direct is also saying that if this task is executed, we return the result of this task directly to user, which is useful in cases that you have a task that you want to ask user a question that then the model wants to ask, so we should stop the planning and move forward. Okay, so having this, let me import the task.
So class input is base model or base task? So go up first line.
Base task.
Task.
Yeah, because this task is some basic implementations. And now the only...
.py, it was base model, right?
Yeah, because that's the main model base task is inherited from. But we inherit from base task because we implemented something in it.
Okay.
Yeah.
So you need to import that.
Yes, yes. And then simply we need to implement this execute function here that right now I'm going to simply import the date time, and then let me see if I have any
definition within the class.
get current date time. I don't memorize this. Okay. Now simply I copy this, that gives me the current date time. And then I want to return this in a specific style. I copy this. So now I simply return this date time, and I can give the some explanation. The next peel time is, and then plus str now dot, and now I want to specify the format that I want the time to be returned. Okay, this is as simple as this, that you can define a task that does something and returns some information. To enable this task, to attach this task to our openCHA, you simply go to the types, go to the task types, define your new task here with the name my peel time, and then in the types, you make it visible to the classes available tasks. That simply you import from tasks.myPeel, import myPeel, and then simply make it available. Now, if I run the openCHA again, if I don't have
So
any.
when you define a new task, you need to run it again.
Yeah, when you define a new task, you need to run it again. And the simple thing was that we just simply put some descriptions here and implemented this execute function. This input represents the inputs that you are going to explain here. For example, if you have time, return these things. You will see in the next session that if you have time, you can provide the format or the URL and so on. And then inside this input array, you will see your data in a proper manner returned to you here. So all of these things are implemented in the core. So you don't need to be worried about handling how this input is passed and so on. So now getting back to our interface, now we should be able to see this my peel time here. I want to select it and then start test it. Okay, I ask when is my next peel time. And now the planner should think, as you see, the peel time is successfully initiated. And then it decides what task to use. Oops, it uses the history. Okay, yeah. It uses the my peel time. The date is returned. Now, in the final answer, you see that my next peel time is this. So this is as simple as just writing some lines of code. If you already have your code somewhere, you can make a function and simply call it in the execute function and return it simply as you've seen here. If it's a simple text, you return it as a text. If it's a structured data, you return it in a JSON format. And then if you want to store it in a data pipe to be used in other tasks that you will explore in the next session, you simply make this true. And then all of these magics will happen in the core itself.